Hello and welcome back to e-sipnayan. For today's video, we're going to discuss the different types of sampling techniques. But before we proceed, do not forget to hit like and subscribe so that you'll get notified once you upload new videos. The learning objective for today is for you to be able to identify a sampling technique used in data collection. We first define what sampling is. Sampling is simply the method or technique wherein you are going to take samples from a population. Now we have two major types, probability and non-probability sampling. In probability sampling, each member of the population has a known probability of being selected in the sample. This is also a type of sampling wherein each member of the population has equal chances of being selected as a sample. Most of the time, probability sampling is preferred in quantitative statistics. For non-probability sampling, it's also called bias selection because there is no recognized probability that one member will be included in the sample. Most of the time, in non-probability sampling, bias is our selection type and it will be based on the preference of the researcher. This is the hierarchy of sampling techniques. We have probability sampling and non-probability sampling. Under each of them, we have four other types of sampling which we are going to discuss a little later. Let's first deal with probability sampling, and there are four. The first one is the so-called simple random sampling. In simple random sampling, it is selected by using chance or random numbers. That is the very usual example. Each individual subject, human or otherwise, has an equal chance of being selected. So some other examples are draw lots and random numbers, or selecting random number or the so-called random number generator. So it's simple random sampling because it is only consisting of chances or by chance. The selection is happening by chance or really random. The next type of probability sampling is the systematic random sampling. It considers every nth element of the population in the sample with the selected random starting point from the first Q members. An example is a sample of 10 will be selected from a population of 40 patients. So this is simply means keep counting by 4. So what will be the process here? How will you know what will be your skip count? So basically the formula is the total over n, and we'll have the quotient. Remember that big N is the population, small n is the sample size. So if we get the quotient, that's 40 over 10, and we have 4. The quotient will be our basis for skip counting, or this is the first Q members. So, in terms of procedure, assign a number to each member of the population, choose a random starting point, and so on. So, say for example, we are talking there about 40 population. So say for example, in the previous example, we have a total population of 40 and we want to select a sample size of 10. To get the skip count for systematic random sampling, we simply get the quotient, which is when we substituted, we got 4. So this means skip count by 4. So in terms of the procedure, assign a number to each member of the population. So say for example, this will be 1 to 10, 11 to 20, 21 to 30, and 31 to 40, and numbers in between. So choose a random starting point. It's up to you. Maybe you can use draw lots. For example, you want to start here. This is your starting point. Do this by dividing the number of members by the desired number of sample. So we already did that. The result is 4, which is the quotient Q. It represents the first Q members of the population, and the random starting point will be determined from them by the lottery method. So, draw lots, in other words. For element or from element n, skip count by Q repeatedly until the desired number of samples is completed. So, this is our starting point. So, we are going to skip count by 4. So, 1, 2, 3, 4. this is our first sample. 1, 2, 3, 4. This is our second sample. 1, 2, 3, 4. The third sample. 1, 2, 3, 4. This is the fourth sample. 1, 2, 3, 4. This is the fifth sample. 1, 2, 3, 4. This is the sixth. 1, 2, 3, 4. This is the seventh sample. 1, 2, 3, 4. This is the eighth sample. 1, 2, 3, 4. This is the ninth sample. And then we go back. 1, 2, 3, 4. This is the 10th sample. So we need to get 10, and we were able to get 10 already using the systematic random sampling. Your takeaway here is how many are you going to skip count? That is simply by getting the quotient of the population and sample size. Next is the stratified random sampling. This is the one that involves a lot of computation. So what you're going to do here is to divide the population into groups based on some characteristics. Then a sample is taken per group. So from a group, this is where you are going to take samples. So per group, you'll be getting samples. It is useful only in conditions when the population is divided into homogeneous groups. The groups are called strata. That's why it's called stratified random sampling. And we're talking about here what types of groups. We're talking about homogeneous groups wherein the members or the elements of the population are grouped based on some circumstance. This is an example. A sample of 100 students is to be selected from a junior high school population of 1,000, of which 250 are in grade 7, 200 are in grade 8, 300 grade 9, 250 in grade 10. If the sample size is to be proportionally distributed, how many samples are to be taken from each stratum? How do we know we are going to apply here stratified random sampling? We can see a jargon, stratum. We also have here the term proportionally distributed. When we say proportionally distributed, it is the same as stratified random sampling. So what we need to know here are some specific information, such as the population size, which is 1,000. We're going to get a sample of 100. And we have other given information, which is the composition of this 1,000. So from this 1,000, 250 are in grade 7. 200 are in grade 8, 300 grade 9, and 250 grade 10. So basically, from the population, it is grouped, and they are grouped based on grade level. Therefore, homogeneous, therefore can be called a strata. How are we going to identify how many samples are we going to take from each group or from each grade level? We follow this formula. Kindly take note. Sample size per stratum or per group is equal to the group size all over population size times the sample size. So for us to know how many are we going to get from grade 7, we simply plug in the values. Grade 7 has a total of 250 students all over the total 1,000 times the sample size 100. For grade 8, grade 9, and grade 10, we are going to apply the same formula, and notice that this is the only value that changed. Then after that, calculate. For grade 7, therefore, we are going to take 25 sample. For grade 8, 20. For grade 9, 30. And for grade 10, 25. And the total, when you add them, should be equal to 100. In case it will not be equal to 100, it's up to you how to adjust the composition of samples per group. And that is how you apply stratified random sampling. Another example, a researcher is conducting a study about the effectiveness of using algebra tile in teaching factoring among grade 8 students. He grouped the students homogeneously according to their mathematical ability. The table below shows the groups formed with the corresponding sizes. How many members from each group will be included in the sample with size 40? Now, it's very convenient that our data is already organized here, except we do not have the sample size. So the total is also the population size, while the sample size is given in the problem as 40. Now, this is stratified random sampling because the students are grouped homogeneously. This is again our clue. Now we are going to apply the same formula. So basically, we have how many categories? 1, 2, 3, 4, and 5. So for beginning, that will be 18. There's a total of 18 beginners. Out of the total, 230, and we are going to get a sample of 40. We are going to apply the same formula for all 5 categories. And then simplify. So you get 3, 9, 23, 3, and 2. So if you try to calculate it, it should be equal to 40, which is our sample size. Now again, if it will not be exactly equal to 40 rather, then it's up to you to manipulate the rounding off, because these are already rounded off to the nearest whole number. So as long as you get 40. Anyway, the sample size is just the minimum that you can get from the population. You can go beyond the sample size. And that is stratified random sampling. Moving on to the last one, we have cluster random sampling, wherein every member from a population is assigned to one group. A sample of clusters is chosen and are surveyed. Clusters are heterogeneous groups from the population. Somehow it's related to stratified, but we are not anymore talking about homogeneous groups, but rather heterogeneous groups. And the groups are called clusters instead of strata. So when we say cluster, this is what we call to the cluster random sampling groups, and the type of groupings is heterogeneous. They are grouped differently according to the controlling variables of the study. So usually, we use cluster random sampling if the data that we want to get would be more on geographical, or if we want to take survey from different regions or locations. Say for example, would be an exit poll. So the groups or the clusters here are the barangay or the present numbers labeled from 1 to 32. How are we going to do here the sampling? We are going to select groups. Unlike in stratified random sampling, per group, we are going to take samples. But for cluster random sampling, we are going to take groups as our sample. So all of the members from the groups taken will be the sample. So the sample is taken through a random selection of clusters, and then all of the members, this is what I said a while ago, will be part of the sample. This type of sampling is used extensively by government and private research organizations. That's why I made an example of exit polls a while ago. And that is cluster random sampling. Another example, a researcher wants to study the effect of certain teaching methodology among the students coming from a particular town. So just like what I mentioned a while ago, mostly cluster random sampling is more geographical. We're talking about towns, districts, countries, and whatsoever. So we are going here to use cluster random sampling because we want to consider a certain town. And we are going to include all students from this given town. And that is cluster random sampling. So in other words, when we say probability sampling, there are 4: simple, systematic, stratified, and cluster. For simple, it is by chance. Systematic, skip counting. Interval is solved by dividing n by n. So we have a formula here, n over n equals q. For stratified random sampling, homogeneous group. Cluster is heterogeneous group. We use using percentage, that is group size, all over population size times sample size. Each group will be a basis in taking a sample. For cluster random sampling, this is heterogeneous, usually geographical. So in this type of sampling, we are considering taking all members of a chosen group. Let's now proceed to non-probability sampling. The first type is convenience sampling, or other called as haphazard sampling. It is carried out on the matter of convenience or ease of the implementation of the part of the researchers. Samples taken are readily available to participate in the sampling. So some examples would be ambush interview or opinion poll. So it is literally defined. It's a type of sampling wherein the gathering of data will be very convenient to the researcher because the samples are readily available to participate in the study. So that is convenience sampling. Next is purposive sampling, otherwise called as judgment or selective sampling. It focuses on samples which are taken based on the judgment of the researcher. Goal is to carefully choose the members of the population which are best fitted to answer the research question. Or in other words, the samples will be based on a certain criteria. If the chosen respondent meets the criteria, then they will be qualified. Hence, purposive sampling because you have a purpose in selecting a particular sample. So example, if a researcher wants to study the toothpaste brand mostly preferred by people, he would go to the nearby convenience store and conduct an interview among all buyers of a particular brand of a toothpaste. So purposive sampling, because you're going to get a sample based on the users of a particular brand. That's your purpose. Next is snowball sampling or chain referral sampling. The researcher chooses a possible respondent for the study at hand, and then each respondent is asked to give recommendations or referrals to other possible respondents. Keyword is suggestion, recommendations, and referrals. So you start by having a specific sample, and that sample will be referring another sample or respondent, and so on. That's why it's called chain referral sampling. Usually this is used when the sample is very limited, or the sample that you want to have are very limited. Then we also have quota sampling. This is the same as cluster sampling, but take note that we are calling the groups as quota. We start by identifying a quota or a group. The population is then divided into several categories according to the control category. Then the researcher collects a sample which has the same proportion as the given population. Individuals will be selected using purposive sampling, not through random sampling. The one that is similar to this or its counterpart in probability sampling should be stratified, because there will be groups, and then from each group you are going to select. The method of selection will be purposive sampling, and that is quota sampling. So for non-probability sampling, we have convenience, purposive, snowball, and quota. Convenience is based on opinion and preferences. Purposive, method of selection, choose the sample best fitted. Snowball, sample, refer other possible samples. We are talking about here suggestions and referrals. And lastly, for quota, categories are created, or quota. After making categories, purposive sampling will be used. You can pause this video and try to answer the following. Then I'll give the answers. Next, you can also pause the video and answer this one. And then I'll give the answers. And that is all for this video. See you again on the next one. Goodbye.